let's see that how you analyze logically. I'm using word logically. This is y-axis, x-axis here. This is what I'll write. Triangle will not appear, no? L by 2 and this is L. Just give them and I'll put in proper shape. Okay, no, yeah. So this is y-axis, this x-axis. I'll give dimensions like this, L by 2, L by 2, and this is L by 2. I want about this point here. High O, I'll call it high OZ. Then IAZ, IBZ, or C we took it, no? Symbol we made, A, no? No, high AZ I want. So we no, what is there in sir? I'll substitute in that formula. So another method is there. So is it an isosceles triangle? Yes, it will be. Now this particular triangle, shall I say it's a 1/4 of the plate? Is a 1/4 of the plate? So this is what that A, B, and C, and this is L, this is L. So this triangle ABC is what? 1/4 of the square plate. So what is the mass of this? Let it be M. Then what is the mass of this square plate? This is a logical problem, very important. So shall I assume that such 4 triangular plates will make a square plate of side length L? And then what is the moment of inertia? IAZ dash, I'll call it. This should be equal to how much? 4m L square by 12. Because what is the mass of total square plate? 4m. Then if I remove these 3 sections, 3 parts, symmetrical part, these are symmetrical parts, then what happened to moment of inertia? Moment of inertia will decrease by 1/4. So from where you are bringing this method? See, I'm not sticking on to any, it's not any formula or any theorem, just as a logical analysis here. Suppose say, if you have structure like this, these are the 2 particles are there at a distance x. Then what is the moment of inertia of this system? You are going to write 2mx square, no? Similarly, if I remove one of the section, if I remove one of the particle, tell me what will happen to moment of inertia? Has become mx square only. Then what is I2? So shall I say I1 by 2? So when you remove that symmetric part, what will happen? The moment of inertia will reduce by half. Here what will happen? This triangle is 1/4 of the square plate. So what is the moment of inertia of square plate? We know IAZ. IAZ is equal to how much? 4m L square by 12. Now I want directly IAZ. So what is IAZ? Should be equal to 1/4 of IAZ dash. Should be equal to 4m L square by 12. So ml square by 12. Sorry, this is 6. Fine. I think it's quite very easy. No need of any integration, nothing. When do you can apply this? Provided symmetry is there, that one. So can you apply this for rectangular plate? No, may not be like that. Only when square plate is there, when you remove 1/4. So IAZ you can determine here. If you know IAZ, so can we calculate the center of mass of the system? Where the center of mass of this triangular plate will be. So somewhere here. I think I should use symbol C here because I'll do one thing. I'll
Sir,
take it. Yeah.
sir,
Uh,
for the square plate, sir, I dash AZ is ml square by 6, no, sir. Why is there a 4?
6 only I made, no?
No, sir, you wrote 4 ml square by 6.
Mass of the square plate, how much? 4m, no?
Oh, okay.
I'm changing symbol ABD. Now center of mass will come here. I want ICZ. I know IAZ. So we know this length is L by 2. So shall we write this distance as Y2? This is Y1. So shall we apply Parallaxis theorem now? Shall we apply Parallaxis theorem? So what is ICZ I want? So here I'll proceed. I think I'll delete this one. I need a lot of space. Okay, no. ICZ is needed. So how to calculate ICZ? I'll apply Parallaxis theorem. First of all, how to calculate Y2? What is the height of the triangle? L by 2. So what should be the Y2 should be equal to 2 by 3 L by 2. So L by 3. Ramanuja? Okay, sorry for disturbance. Okay. Now, is the height of the triangle. So the length of median. So we know Y2 will be the centroidal vector distance of L by 3 from this one. So the distance, this is what AC. Okay, can you hear me now?
Yes, sir.
Okay, my kid came into the room. I sent him off. No, let's come for that. I'll proceed like this. Oh, IAZ is equal to ICZ plus mass of the plate is M into Y2 square. So you know Y2 substitute. We know IAZ. We don't know ICZ. So IAZ is how much? ML square by 6 equal to ICZ. M into this will be L by 3 whole square. Solve it. You'll get the answer. Now I want IBZ. How to calculate IBZ? Again applying Parallax theorem. IBZ. So once you know any one quantity, especially if you know about center of mass, it will be much easier. IBZ equal to ICZ plus M into this distance. I'm just writing it and you try to calculate here. So we know ICZ here. You can't apply Parallax theorem from IBZ is equal to IAZ plus. No. So this axis passing through center of mass. What is C? C is the center of mass of triangular plate. Getting the idea now? This one. Now I want about axis. So an axis can come like this. No, what is there in this one? An axis will come like this. CC dash. Axis passing through center of mass and parallel to x-axis. So that there should be axis passing through point A and parallel to x-axis here. So how to calculate all these things? Again, the same Parallaxis theorem only. So I know IBX. How to calculate IBX? Earlier I shown it. Then from that what happen? You can calculate the IAXX dash. So this is X dash. This is C. CC dash only you can call it this one. No, so same thing, IDZ also we can write it. M into DC whole square. I'll proceed to next part. I want about an axis passing through, I'll call PP dash better. IPP dash. So can we use the formula I x, or so like a IBD x should be equal to what? IPC P dash plus M into y1 square. Parallaxis theorem. We don't know this. We know IBDX. How to calculate about any side? It depends only on height, no? What is IBDX? Should be equal to only M L by 2 whole square by 6. MH square by 6. What is the height of the triangle? With respect to side BD will be L by 2. Substitute that, you'll get IPCP dash. If you know IPCP dash, then you can calculate IXAX dash. Almost everything about the triangle will get over here only. You can see here now. So next again, IXAX dash should be equal to how much? IXCX dash or IP M into y2 square. Perpendicular distance only. Perpendicular distance. So the perpendicular distance BC is what? Perpendicular distance only here. Okay, fine. So this is about the triangle. So let's come to the rectangular